Welcome to Understanding High School Physics. In this problem, we need to determine the direction a plane should fly in order to travel in a given direction during a southerly wind. This problem has actually been removed from the Giancoli Physics textbook from which it came, but it's still a great problem for learning how to apply vectors to real-world problems. So let's see what our relative velocities are. The velocity of the air relative to the ground is just the velocity of the wind, obviously south. If you're not sure what these symbols mean, I suggest watching my video on relative velocity. The velocity of the plane relative to the air is the velocity an old plane would have measured before GPS was invented. We're told it's 580 kilometers per hour, and we need to determine its direction. And, finally, the velocity of the plane relative to the ground is the sum of these. It needs a direction of 38 degrees north of east, and we don't know or need to know its magnitude. As with any vector addition, we're going to add them tail to tip. If you're not sure why I'm doing this, I suggest watching my video on vector addition. I suggest starting with the resultant, and then we could add the other two vectors tail to tip in either order. The question asks us for the direction of the velocity of the plane relative to the air. We know this is 38 degrees, and we're obviously going to need to calculate this angle, which I'll call alpha. These aren't right-angled triangles, so hopefully you know the sine and cosine rules. In case you haven't learned these yet, in the next slide I'll show how we can do the same calculation using only SOHCAHTOA and Pythagoras theorem. For the sine and cosine rules, here are a's, b's and c's. If we use the sine rule, we'll need to calculate this angle, and if we use the cosine rule, we'll need this side. This side would require some long calculations, but the angle is quite simple. This is obviously 38 degrees, and this opposite angle is equal. This is a right angle, so angle B is 128 degrees. Then we can just substitute in those values and get 6.40 degrees for alpha. Let's call the whole angle beta and add these two angles to get a final answer of 44.4 degrees north of east. If you followed that, then great, we're done. Thanks for watching, and please subscribe if you'd like to see more worked solutions and tips. But now let's use good old Pythagoras theorem instead. So we'll add these two sides to make two right-angled triangles. Let's use SOHCAHTOA on the smaller one and Pythagoras on the larger one, and then substitute the first equation into the second. That gives us a nice quadratic, which we could solve using quadratic formula, but I'm going to be lazy and solve it with an online calculator. That returns one real root of 415 kilometers per hour for x. There'd be several ways to get the answer from here, but I'm just going to use cosine on the larger triangle to get 44.3 degrees north of east. Compared with the first method, there is more rounding here, so this answer is probably slightly less accurate, but it would be perfectly acceptable in AP Physics and most other high school courses. As always, please feel free to suggest or ask anything in the comments, and if this helped, please subscribe for more. Thanks for watching.